one.
Alright, we're good to go.
Holy shit, it's got thrust. Oh. Alright.
Okay, so the next part of the video is going to be purely dedicated to finding exactly how much energy is in the potato. There's going to be some math involved, so if you're not into that, there's an annotation, you can skip it. So using math, let's calculate how much energy is in the projectile. To calculate the amount of raw kinetic energy in the projectile, I'll multiply the mass in kilograms with the speed of the projectile in meters per second squared, and then I'll multiply the final number by 0.5. This will get me the amount of kinetic energy in joules. If you don't know what joules are, don't worry, we'll do some comparisons and stuff to just give you a general idea of how much energy it equates to. Okay, so after doing some quick pixel measurements, I have concluded that within 2 frames, about the span of 8 milliseconds, the potato has traveled 15.5 inches. Converting that to centimeters gives us approximately 40 centimeters. Using our 40 centimeter number, if we divide that by the amount of milliseconds it took for the projectile to travel that distance, 0.008, we get a total of 5,000 centimeters traveled in 1 second. Divide that by 100, 50 meters per second. Easy. Okay, so I just did a search on the Google, and I found out that a potato of a similar size to a projectile weighs about 200 grams. Okay, all that's left now is to plug the values into our equation. In place of m, we put 0.2 as in 0.2 kilograms, and in place of s, we put 50 as in 50 meters per second. So if we square 50, we get 2,500. Now we take our number of m for mass, which is 0.2, multiply that by 2,500, which gets us 500, which we then multiply by 0.5 to receive the amount of energy in joules, which comes out to approximately 250. If we know that it takes 10 joules to lift 1 kilogram 1 meter, we can extrapolate that lifting 25 kilograms, about the weight of 50 pounds, 1 meter, would have the same amount of energy as our potato. Alternatively, another example of this would be to lift 1 kilogram 25 meters. I know it doesn't sound like much, but the energy in the projectile is applied over the time frame of about 1,000th of a second. So yes, it would definitely hurt if you got hit by the potato gun. Okay, so when calculating, for instance, what are this thing's chances of breaking someone's bone? Joules isn't really a useful unit, so I need to produce a force in newtons. So in this next part, I'm going to try to calculate the force in newtons. This is the equation which will produce force in newtons. So for mass, we add in 200 grams, or 0.2 kilograms. And for the change in velocity, assuming the projectile goes from 50 meters per second down to 0, we'll just put 50 there. And then doing the quick math, multiplying 0.2 by 50, we get 10. Of course, all that's left is time. So to find time, we take the length of the projectile in meters. So because it's 6 centimeters, it would be 0.06. And we divide that by the velocity in meters per second, which we know from earlier was 50. And that gives us 1.2 milliseconds. Okay, so in its current state, we can't complete the equation. So we have to move time over to the other side. And inserting our value will give us divided by 0.0012 instead of multiplied by 0.0012. So 10 divided by 0.0012 gives us 8,333. So really what I want to find out is how many newtons does it take to break a bone? You know? Like for instance the rib bone. Here we go. This could have something in it. Oh yay, autoplay ads. That's cool. That's cool with me, I guess. Anyways, quick sharp blow that delivers some 3,300 newtons of force has a 25% chance of cracking an average person's ribs. Well, the potato is anything but sharp, although I would say it delivers its impact on about a radius of maybe a square inch or two on a person's ribs. So you would see roughly about 5,000 of said newtons hitting that person's ribs maximum. So could that crack a bone? It mentions that it takes 3,300 of newtons of force to give a 25% chance of cracking an average person's ribs. So I'm definitely going to avoid getting shot with this potato gun because I don't want to absorb any risk of it cracking my ribs. And if it doesn't crack any of my bones, it would probably give you a pretty nasty bruise. Like a really nasty bruise. Hey guys, thanks for watching. And as always, if you liked the video, drop a like on it or share it with a friend. It really helps me out.